Hello and welcome to another one of these ADD videos. Today we're going to look at a few examples of the Wronskian and what it implies. So here's a couple solutions, and we want to see if they form the fundamental set of solutions or a fundamental set of solutions. So what we do is we first take the derivative. So we got y1 prime, and that, using the trig chain rule, would be a negative for the derivative of cosine's negative sine, and then times the derivative of 2t gives you negative 2 sine 2t. And then here, y prime would give you 2 cosine 2t. Then you set up the Wronskian to find its determinant. It's basically that. So you would have cosine 2t, y1, y2. The derivatives would go below. There's your matrix. Find the determinant. So this times this. Minus a negative 2 sine squared 2t. And if we simplify that a little bit, we can change that to a 2 plus factor out the 2. Oops, changing the order there, sorry. And if you remember your Pythagorean identity, that sine squared and plus cosine squared equals 1, or vice versa, cosine squared plus sine squared equals 1, this simplifies to 2 times 1, which is not equal to 0. Therefore, y1 and y2 are indeed plausible fundamental set of solutions, depending on what t0 you choose. Okay, remember, there's that added condition of having this to be true. Y of your t0 has to equal 1, and then the derivative of your 2 0 has to equal 0 for one solution set, and the reverse is true. The original has to equal 0, and the derivative has to equal 1 for the other one. And if that's satisfied, then they're said to be true. So depending on what C1 and C2 you choose, you can combine these to get a general solution like we were solving before. If you remember, we would have C1 cosine 2t plus C2 sine 2t, right? This was an imaginary root with alpha equaling 0 or a equaling 0 to the characteristic equation. You guys remember that, hopefully. So depending on what C1 and C2 are, it could satisfy those conditions and get you the desired fundamental set of solutions. Okay? So make sure you check out the next example. On the next example, we're going to try this one here. So make sure you check it out. This is the repeated root set, okay, where -3 is the r, the solution to your characteristic equation, but it's a repeated root, so we have e to the -3t, and then t e to the -3t, so we can account for that repeat. So practice, practice, practice. Thank you, and have a nice day.